Greeting for Dr. Chu and everyone. We are from Lab S1G1 Group 1. Would like to present overview paper of Fuzzy Inference System FIS regarding the study of the behavior of the green consumer facing the perception of greenwashing. I start with the introduction of the green consumer behavior. Greenwashing can positively or negatively influence consumer satisfaction, loyalty, perceived risk, and perceived benefits. Due to the complexity and uncertainty of these factors, FIS is applied to model these relationships. The system treats greenwashing, loyalty, risk, and benefits as input variables to mathematically evaluate and predict the final output, which is consumer satisfaction. In the following slides, we will cover 5 main topics: how FIS was used in the application domain, how it was created in steps, the strategies followed by the researchers, the outcomes of the study, and future improvement suggestions for similar applications. How FIS was used in the application domain. FIS was used to understand and predict green consumer behavior. Consumer decisions, such as whether to buy organic products, are not always clear and are influenced by factors like satisfaction, loyalty, perceived risk, and perceived benefits. These factors are subjective and cannot be measured precisely. Therefore, FIS was applied to handle this uncertainty by converting these factors into simple categories, linguistic variables, such as low, medium, and high. Then, a set of if-then rules were used to represent how these factors affect consumer decisions. For example, if perceived benefits are high and perceived risk is low, then the level of consumer satisfaction is high. In this way, FIS helps simulate human thinking and provides a more realistic way to analyze consumer behavior. For this slide, we see how the FIS was created in steps. First, the system identifies the input variables, such as greenwashing, loyalty, perceived risk, and perceived benefits. Next, these inputs are converted into fuzzy values, which are low, medium, or high, by using membership functions. After that, a set of if-then rules evaluates the inputs to simulate human decision-making. Finally, the fuzzy output is converted into a single crisp value using the centroid method, representing the consumer's satisfaction. This diagram shows the workflow of the FIS inputs like loyalty, perceived risk, benefits, and greenwashing are first fuzzified into categories such as low, medium, or high. Then, if-then, rules are applied in the fuzzy inference step to evaluate how these factors interact. Finally, the defuzzification converts the fuzzy output into a single crisp value, representing the predicted consumer satisfaction. This allows the system to handle uncertainty and simulate human decision-making. Next, for this slide, we summarize the key strategies followed by the researchers in creating the FIS. They used a large survey of 506 consumers to guide the creation of fuzzy rules, ensuring the system was data-informed. Triangular membership functions were chosen for simplicity and interpretability, while the Memdani inference method allowed human-like reasoning with qualitative inputs. Simulations were conducted before deployment to visualize input-output relationships, and the outputs were validated against survey results. Finally, continuous monitoring was suggested for retail applications to maintain high consumer satisfaction and loyalty. And we continue on this slide that describe the outcomes of the fuzzy inference system. For the input variables, high greenwashing leads to lower consumer satisfaction and loyalty, while high perceived risk also lowers satisfaction. On the positive side, high perceived benefits increase consumer satisfaction, and high loyalty further improves satisfaction. The 3D fuzzy surfaces illustrate these input-output relationships, showing how the factors interact. The model's accuracy is strong, with Pearson R of 0.879 and R squared of 0.773. Overall, The insight is that greenwashing reduces consumer trust, highlighting the importance of transparency in marketing. For future improvements, the researchers suggested several directions. First, evaluating image recovery can improve detection and correction for greenwashed products. Second, expanding the FIS scope to include additional retail variables would allow for broader analysis. Third, using open-ended surveys can help generate fuzzy rules directly from consumer language, providing better insights. Finally, applying the FIS from a first-person perspective allows satisfaction to be captured directly from the consumer viewpoint, making the system more accurate and relevant. Finally, our group include comments on discussing the benefits of FIS for various applications in the future in general, and the tips and practice guidelines developers need to be aware of. The use of FIS in modeling consumer behavior shows how well it handles uncertainty and vagueness in human decision-making. By measuring subjective perceptions like satisfaction and loyalty, FIS provides insights that help both researchers and businesses. For future applications, developers should carefully define input and output variables and membership functions. Validate fuzzy rules with real data, combine FIS with surveys or expert knowledge, and monitor system outputs to adapt to changing consumer behavior. Overall, FIS is a flexible tool for areas where human perception, uncertainty, or imprecision play a big role, such as marketing, healthcare, and environmental decision-making. That's all from our group presentation regarding the overview paper of FIS. Thank you.